everybody welcome Mike Puckett from SolidWorks Corporation. He's going to talk to us about SolidWorks certification and CSWP Prep. Without any further ado, I guess I'll let Mike take it.
Thanks. So if we see questions come up, will they come up on there? Or
they're coming up on my computer also. If anybody asks questions here, just repeat them so that people watching remotely can hear it.
Yeah, luckily there's only 3 of us here, or 4 of us here, so that's could be too many questions. I'm assuming they can hear me okay then.
Right. Okay. He'll man the questions that come in through Dory.
Okay, perfect. So what we're going to do is basically spend the next couple of hours talking about CSWP or certification preparation in terms of that. I manage the SolidWorks certification program, the technical certification program for SolidWorks. I've been with the company for about almost 10 years. So my background is I actually used to design products or design molds for plastic products before I joined SolidWorks and stopped designing stuff. So that's kind of my background. So I was actually an early certified user back in the day as well. And I've been with the certification team ever since. So so thanks for joining us today. And then if there's any questions, pose them as they go along, but we'll kind of work through this stuff here. So what I'm going to do with you guys today is basically show you, we're going to work through a sample exam. So in preparing for any of our certification exams, we offer sample exams for all of them except for the top level ones, so the expert exam. And so what that means is what we're going to go through today, you guys can go online and download it and work through yourself if you'd like to. In this particular case, for the CSWP exam or the professional level exam, it's broken down into 3 different parts, or what we call segments. Segment 1, segment 2, segment 3. Segment 1 is the most difficult segment. Segment 2 would be the next the next least difficult, and then segment 3 would be the easiest one. So the biggest tip there that I can give you guys today, if you're going to take the segments in reverse: 3, then 2, then 1. So it just worked out that way by sheer luck. It was not a plan. So the thing is, a lot of people will take segment 1, they'll fail it, and then they'll get frustrated and never come back. So take segment 3. It's all the assembly stuff. It's pretty easy. That'll give you some confidence, and then you can kind of work backwards from there. The other nice thing about that is that a couple of years ago, about a year and a half ago, we took our sample exams, and they're actually embedded into our tester software now. So when you download this file, it's 32 pages long, and it walks you through the entire process of how to take the exam, and it's done in our tester system. So that allows you to go through and get familiar with how the system works, and how to access it, and all that other good stuff. So we're not going to go through all 32 pages. We're just going to go through the one sample that this deals with, but we'll go through it step by step. So this is the part that we're going to build. All right. What's going to be, I'll ask for a little bit of patience with this, is I'm going to be switching back and forth. So I'm working on just one computer with one screen here. So I'm going to be tabbing back and forth as little as possible. I have this stuff, I have it printed out on paper next to me. So I don't have to come back and reference this drawing too much. But when I want to point something out, we'll come back to this drawing and I'll show you exactly what I'm talking about. On the image in front of you that you'll see, there's a few arrows on the screen there. What we do on here and with the exams is that if let's pretend this is like an actual exam model from one of the exams or from the CSWP exam, what we do is instead of putting dimensions on everything, we take 5 or 6 dimensions and we put letters there instead. And then we assign variable values to those letters. And so what that allows us to do is take this model, for instance, and we can vary either all 5 of these or 6 of these dimensions through a different range of numbers and produce, within just a few minutes, like hundreds of variations of this model and upload those into the test. And so that's why we use the letters in there. There's a couple of things to always pay attention to when you take our exams. Because we don't have the ability to see how you model something, what we do is we take this part and we say, okay, this is what we feel is the most efficient way to model this, so it should take you this long to do it. All right? So like on this part here, as we go through it, I'll show you like what I feel is the most efficient way with some shortcuts and things, and point out how you could do it a different way. And it might take a little bit longer, but then you run out of time in the exam. So because we can't see what your features are, we look for, there's two different things that we can look for. How much a part weighs, all right? And then in the case of an assembly, where the center of gravity is, all right? So if you're gonna model a cube that's 1 millimeter by 1 millimeter by 1 millimeter and assign it a material of brass, okay? No matter what software package you model it in or how you model it, if it's right, it's always gonna weigh the same amount every time, okay? It just physically can't weigh anything different, right? So that's, on this part here, if we model it correctly, we'll hit a certain value of mass, and that's it. It has to be that value if everything's correct. If it's off slightly here or there, your geometry is off slightly somewhere in the model, okay? To give you some background, I was practicing this again this morning at Starbucks before I got here, and I probably sat there for half an hour. I was wrong. Something was wrong on my model. And I had to email the guy from my team and said, what am I missing here? And then while I was waiting for him to reply, I figured it out exactly what it was. I had a radius that was incorrect. And once I fixed it, boom, I hit it within 3 places in grams, okay? 3 decimal places in grams. So that's why it's important to pay attention to the origins in the case of an assembly, and then also for the materials, okay? Depending on what your default material is in SolidWorks, it could be steel. If we call out brass as the material, you can model it correctly, but it's going to be, the value's going to be wrong, right? So we always call out, you'll see over here, we always very clearly call out the unit system, and it's always going to be in millimeter, grams, and seconds, okay? We're a international worldwide company, so the rest of the world uses the metric system, so we do it as well. I like it because it's one less number. I used to do a lot of work for Gillette, and it was all the metric, and inspecting that stuff was one less number, so I liked it. So we called out here. We also, in this case, the part origin is arbitrary because we're not asking you for the center of gravity on this. It doesn't matter, okay? But in the case of an assembly, we would point it out clearly in the drawing. It will show you where the reference, or where it's at. The material, it's always going to be something basic like steel or brass. It's never going to be some material that's buried way down in the material selections. The other thing is we're never going to change the density of it. All right, that wouldn't make sense to do it because the density is the density. And then we're not trying to test people on their ability to catch those little things. We want to try and test you on your ability to use the software. So there's no hidden tricks or stuff like that with any of that stuff there. But pay attention to those materials. That's always most common thing when somebody says, what did I get wrong? We look and they have the wrong materials assigned. And that's quite common. In the case of this part here, you can see we have a few variables here. The variables will be called out in the tester client window. So in this case, you have A, B, C, D, E, F. And for this part is just a whole lizard call out. Okay, so that's just defining something. But then you see X and Y, we actually do some equations, all right? So in thinking about how, okay, so the process of this part is gonna be is that we're gonna model this part and then we're gonna change those variables, okay? And then we're gonna ask you how much it weighs again. So in the first instance, you'll model this part and we say, okay, how much does this part weigh? And we'll give you 4 multiple choice answers. Right, that makes it easy because you know if you're on target, right? It's like, okay, here's what I have, so I must be completely correct at this point. Then we ask you to make some changes, or we have you change the variables, and then we tell you input the weight of the part down. All right, so now you're off on your own. You have no reassurance if you're on the right track or not, okay? And then what we do is we actually change the geometry of the part as well. So we're testing your ability, for your ability to design a model that can withstand changes rather easily. Because we all know, especially if you have a manager, they love to change things, or a customer will love to change things up until the very last little second. You know, as an engineer, probably one of the most frustrating things is like the changes that keep rolling along. And so can you build a part that's robust enough, can you model it where it can withstand those changes, all right? So, in this case, the red arrows point to all those variables in there. So on here, what you can do if you're not familiar with equations or or variables, you can type in all these things, right? You can go back and it's like, okay, I modeled this, I'm correct. Now now that the variables changed, you can go in and try to make sure that you catch up and change all those dimensions. Okay, and then you can do the math yourself, and you can keep your fingers crossed that you caught all the dimensions, and then move forward, right? Or you can do it the way that I'm going to show you, using equations and variables, so you don't have to, right? So that's where we talk about like the most efficient way to model things. Okay. So this is basically what the part should look like when we're done with it. Okay, and there's our 4 possible answers there. So I know, excuse me, which one that answer is going to be. So we're going to switch over to SolidWorks. Okay, and we're going to work through this part. All right, so I'm going to try my hardest to come out with the exact answer from the get-go. Okay, and not go back. But if I do miss something, it's just kind of a really clear indicator of like sometimes not being able to pick up something, or paying attention to the drawings. This part, while not super complicated, has a few little tricks in there. One which caught me this morning that I now have circled on here to make sure that I know not to do it again. But it's basically just a matter of paying attention to things. The nice thing is, like, if back on this sheet here, okay, with the answers that are provided, we actually give you a tolerance. Okay, so if the answer is, if it's A, 141.39, we're probably allowing you to enter somewhere between 141.25 and 141.50. Okay, so we're actually giving you a little bit of like wiggle room there, if you will, right? So it's from an engineering standpoint, that may be a little dangerous. If you're building a bridge, it's like, well, okay, we're close enough. That's probably not a good idea. But on here, it's, we want people to have a little bit of chance on there, so it's not too frustrating. Okay, so what I'm going to do is I'm going to start a new part, and it's metric. So I have my templates already set up in here. So I'm going to select a millimeter part here, and what that's going to do is basically it just sets up my settings with millimeter gram seconds. That's it. All the dimensions are in there. Everything is in that scale. All right. The next thing I will mention is you're going to see me using the shortcut toolbar a lot. Okay. This is just because this is the way that I got used to using SolidWorks when they introduced it, and it's the way that I like to work. So what I'm basically doing, I'm going to hit the S key on my keyboard, and a toolbar like this is going to pop up. And it's going to pop up wherever my cursor is at on the screen. Okay, no matter where it's at. So right now, since I'm in part mode, I have a series of tools that are available to me that I've customized at the part mode level. Okay, so you can see some various things here. If I want to do some surfacing stuff, I want to save it. You'll see on each one, save is on there, because it's a quick way for me to just save parts through there if I want to make a drawing of it. Okay, but when I go into sketch mode, you'll notice that it completely changes. So let's just start with this part. And let's go back here so you can see exactly what it's going to look like. Let me go back to the drawing. We're basically going to start with a square shape, right? And then we're going to create this little, I call it the wall right here, the little like wall that goes up. And then we'll create these 2 cylinders, and then we'll work on this cutout area down here. And then we'll we'll finish everything up with fillets and stuff like that.
Where's the origin indicated in this, Mike?
So he's asking where the origin is indicated. On this part, it's not indicated because it doesn't matter. Okay, good. All right. But the way it's dimensioned, I would kind of say, I'm gonna use this bottom right-hand corner. Okay. Because that's the way it's kind of dimensioned off there. Right? So let's go back to SolidWorks. So we'll start on the top plane, and we'll click Sketch. So now if I hit my S key, you notice my toolbar is completely different in here. If you guys aren't using, some of you guys may be holding down the middle mouse button, or the right one. So the mouse gestures, I think is what they're called. I'm not a fan of mouse gestures. At one point, I had all my mouse gestures mapped to the S key. Mm-hmm. So I would just launch S key. So
you're old school.
I guess so, but I guess it was on here. So this works just like in a toolbar. You can right click, customize, and drop stuff down. So if anybody wants to play with it, that's basically it. It's just a shortcut toolbar key. So I'm gonna hit the S key, and right here I have corner rectangle already selected. So we'll start on the origin there, and I'll just drag this way. Let's get that normal too. Skew a little bit. And then now let's start dimensioning it. So if we go back to our drawing here, we notice that the size is A in one dimension or one direction and B in the other direction. The arrow's covering it up, but can't move it actually now. It's in there. But I have it sitting next to me. So let's go back back there. And actually, there's one thing I wanted to do before we started this. So missed one step. So let me get out of that sketch. Let's go back and let me just delete it. We'll kind of like start over since we're only one feature into it. Let's set up our equations first. All right, so we have the equations over here in your feature tree. There's a folder for equations. Okay, that may or may not be showing for you by default. So inside the options, there is, let's see, under display, or is it here? Okay, so under feature manager, under the system options, if you don't see a folder over here, this may be set to hide or it might be set to automatic. So if it's set to automatic, the folder will only appear once you create an equation. All right, so I've set it to show, just so it's always there. That way I don't have to go in and remember where to set equations. I can come over here, right click on equations and go manage equations. All right, that's the simplest way. So if a folder's not showing up there, there's a feature manager option that needs to be turned on. So if we go back and look at the variables we have to set, this is our list right here. I need to set this list with the exception of F. F is just a feature callout, so I'm not going to put that in there. Again, I have this sitting here on a piece of paper next to me, so I'm just going to work from that piece of paper. So under global variables, I'm going to type in A and then just hit tab, and the value of that is going to be 213. And hit enter. The next one is going to be B, and then tab, that's 200. C is going to be 170. It's very critical to enter these values correctly because this is what's going to build your model as well. D, 130. E is going to be 41. And then we skip F, and then it goes to X and Y. Now, X and Y are the two equations. You'll notice I haven't switched out the equations. I'm still going to stay under the global variables. So this is going to be X. And now X is called out as A divided by 3. So I'm going to go here and hit A divided by 3 and then enter. And you'll see it actually gives me the equation over here. So you don't have to come down to the equations. I'm not quite sure why the equation is down there, because you can do the equations in the variables. So it's easier just to manage up here. The next one is Y. And this is going to be B divided by 3 and then plus 10. And that's it. So our equations or variables are all set up. And then click OK. If you expand this folder, there they are. They're always there. Okay, they give you the values that they equate to if there is an equation in there. So it is still under the equations folder. These are just variables, but there used to be a different way to do it back in the day with linked dimensions as well, which I think some people still teach to. I think this is the easier way than doing linked dimensions. They're a little more difficult to find. Yeah. All right, so let's get back into that sketch. And let's grab that sketch that square again. Okay, and then so our dimension on the left-hand side over, this is A. So now to use a global variable, what I'm going to do on the keyboard is I'm going to hit the equal sign, double quotes, then A, double quotes, and if you're really quick on the enter key, you can hit enter twice and it'll put it in there. All right. So there's 213. If we look at our equations, A equals 213, and we have the equation symbol next to it. All right, that's the critical thing you want to see there. Because if for some reason it just puts 213 in there, it's never going to update. All right, so that's what you want to look for. This dimension down here is the B dimension. So again, equals, then double quotes, B, double quotes again, and then you just hit enter and enter. And there's the size of our block to begin with. All right, and we're going to type in these variables over and over, so you'll get used to that double quotes. You have to use double quotes. It doesn't use single quotes. We've tried it, and it has to be double quotes. So, which is frustrating because now you have to hold the shift key to do it. So, but anyways, you get used to it. So the extrusion we're going to extrude this next. This has two different levels to it. This little boss that sticks up over here in this view, it sticks up 10 millimeters above the rest of it. So the main part of it is at 25 millimeters. So I'm just going to extrude it to 25, and then we come back. I can easily do the math in my head. 35 minus 25 is 10, so I know how to do that. So we're going to just go 25 millimeters on the extrude. So I'm ready to extrude this. Hit the S key. You see I have extrude on there because I know I'm going to use it a lot. I'm going to hit 25, enter and enter. All right, and there's the base. There's the basis of our block. Okay. One of the second biggest tricks that I can give you guys on the exams is to save your model at every step. All right, you can't imagine how many times we see people who are they'll get 5 or 6 steps into it and something will happen. The software will crash or their battery will die or something will happen. Usually the software crashes or something, and they're lost. You have to go all the way back to step 1. Okay, so a good CAD person always saves their models as they go along, right? So we'll just save it on the desktop, and there's the basis of our model now. All right, so the next step that we're going to build next, or that we'll do next, is we'll do that wall. So let's go back here, and that's this curved area in here, and that comes along through the side over here. Now, the reason I want to do that is because I studied the drawing really quick, and I've done it so many times. Is this pocket in here is a 9 millimeter offset, so I don't have any information to draw the pocket. I have information to draw the wall, and then I can use the wall to reference the pocket. So I know I need to do that first. That's just basic kind of modeling or drawing reading at this point. So we'll select the surface and we'll start a sketch on here. And I'm going to draw just the basic shape. And there's a couple of good tricks in this step. So we'll go slow and make sure that everybody can see what I'm doing. So with my line tool, I'm going to just draw from here, and I'm going to go up horizontal. Now when I'm doing click, drag, click, okay? So I'm releasing the left mouse button as I move, okay? So when I move away from that point, it's still in the line tool, right? When I come back to the end point, oh, I missed it. Well, I didn't actually. It'll turn into an arc. So let me do that again because I kind of slipped a little bit on the mouse. Again, as I come, and once I drop that point and move away, when I come back, you'll see it turns in, the symbol changes. And now I have an arc, okay? So I'll draw the arc, and then I come over in here and do another line like that. What that just saved me is that just saved me a step of having to hit escape, go and find the 3-point arc, drawing 3-point arc, hit escape, grabbing the line tool, and coming over and drawing again. Okay, so now we're trying to sketch things quickly as we can. To dimension these, this is another variable. This is the C variable here. All right, so you can see it's to the outside of that shape, not the inside. So it's outside, and then the thickness is actually a lesser value from there. So we're going to grab our dimension tool, and I'm going to grab from here over to here. And this is just the same thing, equals, double quotes C, double quotes, and then enter, enter. And the same thing over here. All right. Now, when I drew that, okay, I got one more dimension to make. Okay, let's go back here. I'll show you the dimension. There's an 80 millimeter call out right here on both sides. Now, in here, we could, if you want to, I'm not going to say it's either good or bad to dimension 1 and make it equal. I think that since it's called out twice, that perhaps maybe it's one of those may change down the road. So the guy that, or maybe it's just a terrible drawing. Okay, right? You could put 80 times 2. Okay, so I'm sure there's some GDT stuff that probably comes into play here. On our drawings, we're trying to be overly clear with the dimensions, if anything. So there's no drawing standard whatsoever to the drawings that we give you. We're just trying to give you as much information that you need, or that you can have. Sometimes it's over dimensioned, if you will. So on here, I'm just going to go ahead, since it's quick. I'm just going to grab these, and I'm just going to put an 80 millimeter dimension here for both lines. Okay, and because we drew it right, it's fully defined. I prefer to use fully defined sketches. I don't know too many people that don't, because that means things can move around. So, but we're fully defined, all right? So how do I get that 15 millimeters now? I can go back and I can draw it, if I want to, but why not just offset it? All right, so let's just, I'm going to pre-select these. I'm going to control select these three entities. And on my shortcut toolbar, I have offset. And we get a preview of the offset. So it's set to 10 millimeters. This is going to be 15. So I'll hit 15, enter. But I'm not going to end there. I'm going to come over here. I'm going to select cap ends. And I'm going to switch from arcs to lines. And then click OK. And so if you see what that did is that drew that line for me.
Fully enclosed your sketch.
It fully enclosed the sketch. Now I have a sketch contour, and you could see it with a different color blue. I didn't have to either convert the entity, trim, do that twice. I didn't have to sketch a line, and it did the work for me. All right, so those are two little shortcuts in there that can help you sketch a little bit quicker. So at this point, we're ready to extrude this shape. We have that dark shade. As far back as a few years ago, we introduced sketch contours that shows you that you have a closed contour that can now be extruded. I believe that's going to be, it's called out as 95 millimeters up here at the top from the bottom of the base. So it's 95 up there. So we're sketching on a different phase. We're actually sketching 25 millimeters up. So again, instead of doing the math, what I can do is I can just do an extrude. And in this box over here, I can go 95 minus 25. Okay, I know it's 70 millimeters, but maybe I haven't had enough coffee yet, and simple math is not working in my brain yet. So you can type that in all over the place in the software. You can do simple, or you can actually do like full-on trigonometry and stuff in those boxes. And there's our shape. Okay, there's the basis of our shape now. So we'll save that once again. Again, hopefully we're building this with the right dimensions, and we'll get to the point. But we'll just keep moving forward. The next thing we're going to do is we're going to work on these two, the two bosses, or the two cylinders. I'm sorry, the two cylinders that go through here. Something to pay attention to. One of the other things that caught me this morning. Okay, if we look here, they somewhat look a little the same. Okay, but if we notice here, the diameters are these. This one, the inside diameter is E, the outside diameter is X. Over here, the inside diameter is E, but the outside diameter is Y. All right, so it's not symmetrical. Right, so that might have been a little trick that the guy that designed this threw in there to kind of to trick some people. The other thing is that because when we vary these models with all the dimensions, your model may look slightly different than the pictures that we give you because we just use the one image from the very base model. All right, so if it should look pretty much similar, but like this one, you can see based on like the top of this red arrow, we could probably see that the diameter is a little different. All right, but it may be instead of, if it's only like a 5 millimeter difference, you won't see it much in your model. So it may look the same. Another thing here is these actually stick out 10 millimeters from this front face. And then the extrude is actually a variable as well. So let's deal with that 10 millimeters offset first. So what do? I can create a plane if I wanted to, right? Okay, I've got a plane there. Okay, and I can just control drag at 10 millimeters and be done with it if I wanted to. But let me show you how you can use the feature to complete the offset for you. So we'll sketch on this face. And I'm just going to sketch a couple of circles. And because it's called out in the center of that wall, I basically just have to grab the midpoint, and it's already located. The circles are concentric with each other. I'm just going to roughly sketch these. So again, the inner diameter of both of them is E. So we'll grab the inside one first, and we'll assign E to this one. Okay. And then on this side, this one is, the outside diameter is X. All right. So there's our sketch. So now how do we handle that 10 millimeter offset? Well, let's grab the extrude tool. And up in the top of this, up here, we have this from box. So from, we can actually do an offset. And in there, we're going to type in 10 millimeters. And now you start to see a preview. That's why it's always nice to have the preview on. So you just hit this little button right here, reverse direction, and it reverses the direction of the extrude now. And then in here, it's the same thing with the dimension as with the feature using a variable, equals double quotes D, just like that. Okay, so
if you type in equals D, doesn't it show you like?
Yeah, let's try. So yeah, he wants to know if we type in just something, it just equals D, if it'll show. Let's try, when we do the next one, let's see if we can play around with it a little bit and see if we can try some different things. Because I don't want to say yes or no, because I'm not 100% sure. So there's that one. Let's just save this. Let's come over and sketch this next one, and we'll try a couple things. So again, same thing, just a circle on the midpoint of that line with another circle inside of it. I like to dimension the smaller dimension first. So it shrinks down to the small and then kind of big out, or you can grow out. That way lines don't end up on top of each other. You're trying to select weird things and stuff like that. And this one, remember, this is different. This is Y on this side. This is one that caught me this morning as well. All right, so let's go back in. Let's try that extrude. Again, we're going to do the offset of 10 millimeters. Flip the direction, and then if we start typing in here, equals. So you can hit equals and go through here and select it like that. If you want to move your mouse around. If I just put D.
It shows it.
It does, yeah. I think you still have to move your mouse over here and select it. Yeah. So what I'm doing is when I'm coming into this feature, my mouse is way over here, and this box is, well, maybe I'm not. I'm trying not to move my mouse more than I guess I need to. So that, yeah, there's a couple of different ways to do it, but yeah, it does kind of work. I've gotten in the habit of just this method, and then again, if you can hit it really quick, it'll do enter twice. It'll complete the feature. All right, so sorry, I was taking a drink of water there. So there's that part there. The next thing we need to do is we need to get rid of the bosses in there, or the stuff that's sticking out. Now, in modeling this, and if somebody has a different idea of the way they would have done this to where we didn't end up with this, I couldn't figure out a way, because we have to get back up. We have to get up to 95 millimeters at this edge up here. So I tried drawing both of these and extruding up, but then you have to extrude the center part. So anybody has any ideas?
I would just do the cylinder solid and then cut the hole.
Then cut the hole. Yeah, that would work as well. So we're basically almost going to do the same thing. We're going to sketch on these two faces. You guys can probably guess what I'm going to do. I'm just going to grab that edge. I'm going to use the Convert Entities tool. Okay, and because I already had that selected, wrong edge. I'm going to select that edge, and if I, come on. It just grabs that edge, and you can see it's a contour already. Now when I go in here, on my shortcut toolbar, I have Extrude Cut on here, and now you just have to come back here, double click on that face, and hit OK, and it's gone, right? So it's really quick and simple. Again, sketch on this face. You can see my mouse is pretty much staying within the graphics area as much as possible. I'm not running up to the toolbar very often, if any. And the nice thing about these, this toolbar, on my computer, I probably have these toolbars going back to like 2002 or 2001. And I've built up a library every year. So every time I switch computers, I just drag that folder over and I run it, and it sets all my things up. The other thing is, like with 2018, I'm not sure what version you guys are using. There's a thing now here, there's a login now for SolidWorks as well. So the nice thing about, remember you can transfer licenses. You guys ever done that? Like check in a license, check it out. Mm-hmm. So you can actually do logins now instead. So instead of having to check in a license, you can log in using your SolidWorks ID. And if you're logged in a different computer, it'll check that license back in for you, and then it'll check it out on the computer that you log into. The other nice thing is that it'll set up your entire user interface to match your other computer as well, which is kind of cool. So it kind of carries those things around. So you could essentially, like if I'm going to get a new computer, I probably don't have to carry those files anymore. If I've logged in, I would just log out on this computer, get my new computer, log in, and it should set everything up the same way. Fingers crossed. But so anyways, so there's that part of it. Okay, let's go back and look at our drawing, and we're going to start working on this little boss here. Again, much like the wall that we built here, this cutout references this boss. So let's go ahead and just complete the boss. We'll do even the fillet. We'll do the whole here, and we'll come back and we'll do this little kind of like I call it the lake or the trough at the very end of it. So this is basically 30 by 30, and it sticks up 10 millimeters above that surface. So this is just a super simple feature. I'm going to sketch on this surface. And again, this is going to be a corner rectangle. And then just some dimensions. So 60 by 60. And then an extrusion of 10 millimeters above that surface. So 100. All right, so there's that. Let's go ahead and put that fillet in. And that fillet is different than the rest of them. So it's one of the things you really want to watch out for. It's a 15 millimeter fillet. And I have my select through hidden lines through body, so I don't have to rotate around. And there's the fillet. Now onto the hole wizard feature. It's basically just an M8 counterbore that goes through here. So I'm going to pre-select that face. Hole wizard's on here. It's actually it's also on my shortcut toolbar as well. Since I did this morning, it remembers the last toolbox feature I used, so it's all pre-selected. You will notice in mine that I'm using custom sizing because my database, my toolbox database is referenced off what we used to use at the mold shop because the bolts that we would buy for the master car were different than the other stuff that SolidWorks uses for some reason. So we had all custom sizing for our bolts to sit the way we wanted to. So in my case, I had to come in here and I had to set the 15, 30, and the 10, but it's even called out in the instructions. All right, so we make it very clear just in case, because if I use the standard sizing, it's going to be wrong, and I'm going to either have too much or too little material, right? And that's going to affect the weight of my part when I'm done. So we actually make sure to call that out. So this is all set from this morning. I'm going to go to positions here. I'm just going to rotate this around so it's parallel to my screen. And I'm just going to kind of locate the position there. I'm going to select, and then since I'm in sketch mode, basically, I can grab a center line. And because it's on the center of that, in the center of that pocket or that boss, what I can do is I can grab a center line, and I can just grab this point, drop it on that line on the center point, and that's positioned. Okay, really quick and easy way just to do that. Okay, and then click OK, and there's our counterboard. Okay, we only have a couple more features left. A little pocket in here, some chamfers up here, and then the fillets in various areas. So we'll save this, and let's work on this pocket next. So I'm going to select this face, and we're going to start a sketch. I'm going to leave it selected, all right? I don't want to deselect. I can come back and select if I want to. With it selected, I'm going to grab the offset tool, okay? And now, so already you can see the geometry is starting to build for us, or the sketch geometry, if you will. Obviously, it's offsetting the wrong way, so let's reverse it. And the offset distance is not 15, it should be 9. So I'll hit 9 and then enter, and there's our offset. All right, so yeah, let's see, 1, 2, 3, 4, 5, 6, 7, 8 sketch entities that were created for us in just a matter of seconds. Okay, I didn't have to draw this, draw an arc, draw another line, and then go through and dimension it all. That would have been crazy. Okay, so there's basically, that's our shape. That's it. We don't have to do anything else. There are some fillets in there. There's an argument about when to put fillets in the tree, when not to. It depends. I will tell you on this. In this case, this fillet has to be in the sketch, has to be an offset of that fillet, or the part will be wrong. Okay, and in the drawing, it actually calls out, there's a 9 millimeter dimension offset between these two fillets, okay? If we dimension this, measure that, you can see that radius is 24 millimeters, okay? So that's not called out anywhere on this sketch, okay? This morning, what I did is I thought I would come back in and put that fillet in, and for some reason, I was 20 grams heavy every time I did it. I couldn't figure out why. And then I looked at the drawing and I said, oh, that's what it was, okay? And so what I had done is I was waiting to put that fillet at the end, okay? So in this case, I needed to put the fillet before I did the sketch. So I learned my lesson this morning. So there's that part of it there. And now we just need to cut down. So we're at, this dimension is called out as 5 millimeters down here at the very bottom. So it's 25 minus 5. So we need to cut down 20 millimeters into that surface. Extruded cut, I'm going to put 20 and then enter twice, and there's our pocket. So let's add some fillets, and then we'll do the chamfer at the very last. So in that pocket that we just cut, it calls out 10 millimeter radius 6 times. And that's how I caught it this morning, because I went to start around and I had 7 selections instead of 6. So that's how I caught it this morning. So 10 millimeters, and then let's go ahead and we'll grab, we should have 6 selections here. 3, 4, equals 5, and then up here will be number 6. Okay, so there's 6 there. The outside of the part also as well has is a 10 millimeter fillet. So I could include it in the same feature if I wanted to, but I know that in the next, one of the steps further on down, this pocket gets consumed, all right? So if I put that fillet as part of that feature, guess what I'm gonna have to do? Go back and do those fillets over again. That's why the next kind of tip I have for you guys is that is when you're in the testers and you're taking in the tester software taking the test, you can click through the questions and go through and see what the changes are going to be. And that's a nice benefit to have from like one of the products that you guys are designing. You don't know what the final product's going to be, right? It's going to change 100 times. And imagine if you could say, okay, well, this is how it's going to be. So let me just design to that right now. So click ahead in the questions and see what's going to change, and then come back so you know what's going to be updated. All right, so let's go ahead and we'll put those outside fillets as well. It's already set to 10 millimeter because I just created a 10 millimeter fillet, and we'll grab these 4 corners. Okay, and the last thing that we should have to do is the chamfers on these edges, and they're called out as 2 by 45 degrees. So grab my chamfer tool, type in 2, and just select these 4 edges. Okay, and then we'll click OK, and then we'll save it. So there's one big thing I haven't done yet. Can anybody guess what that is?
You haven't added a material.
Haven't added a material, yes. That's it right there, yeah. So, didn't want you to see that. I'm going to save it. So under here, I'm going to right click on materials and then edit the material. You can set these up. If you find yourself using constant like materials over and over again, you can manage your favorites and you can set these, 8 different materials. You can have up to 8 in there. And you can set these materials whatever you want. So these are the ones that I tend to use most often. In this case, it's called as alloy steel, which I don't have in here. So I'm just going to come in here. I'm going to hit edit material, and again, steel is already selected, and I'm going to find alloy steel. Again, we're not changing any of the densities, and it's just a basic material. We're not trying to get you to find like some oddball, like you can get down really far into some of these lists. They have like subfolders and subfolders like that. So we're not doing that. We're basically just keeping it to basic material. So in this case, alloy steel, hit apply, and then close. And I know it's correct because it matches the color of my drawing. Okay. Let's just save it again. At this point, we should be able to measure it. Okay. So what we've come up with is we have a mass right here. We can change the options. I have mine set to 4. It goes back to my old QA days of just loving to see numbers. 14,207, 349. Let's go back here. And we can see that one of the multiple choice answers is D. Okay, 14,207.34. I think we had, was it 0.37? Or we were close to that. 309 or something like that. So we're close. Okay, so we're off 0.03 probably, or 0.02 grams. I'm okay with that. Okay, so I'm curious as to where that might be, and something I'm not quite sure where it might be, but so basically that's it. So the answer in this case is 14,207.34. Okay, so in this case we got it correct, close enough. So let's go back to here and see. No, I was at 14,207.35. Okay, so we're actually off 0.001 grams. Okay, I just upgraded Service Pack 4 this morning, and maybe something in there is causing it off. All right, so that's why we put that some tolerance in there as well, because maybe the way the software is calculating the mesh or something in the background is they change the calculation or something, it gets off. But in this case, we're on within. If we had it set to two places, we wouldn't have seen that anyways. Or we would have been fine. Okay, so let's go back and see what's next. So we're fairly good. We got the right dimension. Okay, now we come to the next step. It says, okay, update the part to the following dimensions. Okay, and you can see that now we get a whole new set of values for all of our variables. Okay, this is really where it highlights the reason of why to use variables and equations. Okay, this is really going to show you how quickly we can make these changes. Okay, again, I have these printed out sitting next to me, so I don't need to go back and forth. I'm just going to come in here. I'm going to right click and manage equations. I wish you could try. So I tried this morning. I sent this to the equation guy. I said, it'd be really cool if I could just double click this and change it right there. You know, just like I can, or how you slow double click to change a thing or change a name, basic Windows function, right? I'd love if we could just slow double click these and change the value there. So I sent that into the enhancement request. We'll see if they tell me I'm crazy or just, you know, or they adopt it. So for now, we'll have to hit manage equations. And now it's just coming in here and basically just changing these values. So this one's going to be 209. B is going to be 218. C is going to be 169. D is going to be 125. E is remain at 41. Okay. And then A is still going to be, or I'm sorry, X is still going to be A divided by 3, and Y is still going to be B divided by 3 plus 10. Okay. So at this point, I can just hit OK, and it's going to rebuild that file. Okay. I'm going to force a rebuild by hitting Control Q just for peace of mind. All right, to make sure that it does it. But basically, once you hit OK on in that feature, it's going to rebuild the model with all these new dimensions. All right. So now we can go in and we can measure this part now because we have all those new dimensions in there. Now imagine trying to go back through. How long did that take us? A minute at the most? 45 seconds? Imagine having to go back in and try to change and manage all those dimensions. Okay, you can get yourself into trouble really quickly. I see people all the time trying to complete the exam without using equations or linked values, and it does not work. You run out of time because there's a lot of dimensions, a lot of variables around the place, all over the place. I can see back when we used to use linked dimensions, it was tough to set those up. But now with the equations and using variables, there's no reason why not to use it. So we have an answer here of 151.47, we'll call it. So let's go back here. Okay, 151.47. Okay. So again, at this point, we wouldn't probably tell you or give you multiple choice. You're just going to type a number in and you're off on your own now. All right. So again, that's another reason to be ahead of the ball with those variables. All right. So there's actually a third change that gets done in this part. Okay. And because I usually do this as a user group, we usually only have about an hour, so an hour, 15 minutes. So I skipped one of them. So so we're going to skip that third change, but I'm going to update the variables so they match this step. And then what we're going to do is we're going to come back and we're going to look at this, the changes to the part. So is this the values? I think so. Okay, so you can quickly see there's some changes here. We have to do a cutout here. This pocket actually doesn't disappear, but it changes. And then we have the rear pocket back here that we have to add to it as well. Let's go back to the part and let me just update those equations and variables first. So 221, 221, 211. C is going to be 165. D is going to be 121 again. E is 37. Okay. X is still A divided by 3. But Y gets changed to B divided by 3 plus 15. Okay. Now, in this case, what we do, so we'll hit OK. In the tester software, and this is an example as well, we actually, right here, we tell you, no, the equation for y has changed from the initial part. Okay, so again, anything in the like the building of the part, the tester part of it, we're trying to be as clear as we can for the changes that are being made. We could have left that note out and probably caught a bunch of people on that one, right? Because it changes from +15 or +10 to +15. But again, we're trying to test your ability to model parts, not to take an exam. So that's what, so we'll call those things out. If anything, on the left-hand side of the tester software, when you're in there, there'll be a bunch of information in there. So always scroll down, read through it, and see what's in there before you start modeling. Okay. While we're here, let's take a look and see what we need to do. So we're just going to work through this one and try some things. Okay. So first off, let's go in here. We need to get rid of that counter board that's up in the front. Okay. We need to get rid of the counter board, the boss, and then it looks like it still stays at 5 millimeters. So we're good on the thickness. The 9 millimeter offset that we can see is still constant all the way around. So we just basically need to get rid of that boss, the counter bore, and then deal with the broken geometry that's going to result from that. Okay. One thing that's going to happen is that the sketch geometry is going to get confused because it's going to be missing some things. But that's fine. We can work through that. So at this part, I would probably, there's a couple things you can do. You can save as you're going along. You can have configurations of this part. Okay, it's probably the best thing to do. So for each stage, you have a configuration, so you can go back and reference those. You can save as and then open if you want and have a copy of it. So there's various different things to do. So for here, let's just go here. Let's there's the counter board. Okay, if I right click this and I suppress it, what it's going to do is it's going to suppress all the children feature of it as well. Okay, suppress versus delete is completely up to you, right? It does the same thing. At least with suppress, I can always go back and unsuppress it, and I can use some things if something goes wrong. In this case, all that happened is we just lost that one filleted edge. Okay, I was expecting it to kind of have some errors with here, but since it's gone, it just extended those two lines in there. So we just need to come back in here. It's missing an edge.
You make the new configuration?
I didn't on here. I didn't. No. Yeah. I'm doing this part over and over again. So tomorrow night I'll do it all over and start from scratch again. So we'll just right click on this and we'll just edit the feature. Okay. You can come in and you can select these things and replace them. To me, it's just as easy to come in here, reselect it, and then click OK. What it's doing is telling us it's looking for replacements for these. So you do have to control, select them, and then delete them. And now it can rebuild it. Again, you can, by clicking on it and then clicking the edge, it'll reconnect the reference. Sometimes it's handy. Sometimes I think it's more work than it's worth. Okay, so we fixed that. There's the fillet. Okay, or there's there's the lake, if you will. Okay, should be completely done according to what I'm looking at on my drawing. Okay, we can go and verify there is a, it calls 5 by 10 millimeter radius. So again, because that's a 10 millimeter radius, because we just opened that feature. All right, so we're good on there. And let's come back here. And now let's work on this piece back here, okay? This is a 9 millimeter offset from that back wall and the edges. And then there's a 10 millimeter radius in 3 places, so 1, 2, 3. And as far as the back, so we can see because of the sectioning, which is right here, I believe, it's 5 millimeters as well. They're both 5 millimeters. So come back in here and we'll sketch on this face. Now for here, what I'm going to do is I'm going to just grab that and we'll offset it 10 millimeters, sorry, 9 millimeters. So it's already there, we'll reverse it and then click OK. And then I'm just going to, on this thing here, let's try and offset this. If I remember correctly, you see how it's not giving us a preview? It's because they're not connected. Okay, so if I unselect that one, you see I get a preview for that one. That's the reason why on this one, you're kind of stuck doing 3 offsets, if you will. because they're not connected, which is a little frustrating, but I guess it's just how it works. I don't understand why it won't just offset it, but I'm sure it has something to do with the way the software works in the background. So it has to be 3 separate offsets like that. We can just grab these and drag them and they'll inference each other and they're fully defined now. Same thing over here. This is actually going to be, this will continue on to arc. So we don't want that. We actually want to create a couple of lines there. So we'll just grab the line tool and then just go straight out. And then we'll just do some trimming. And depending on what type of trim tool you like, a lot of people love to use that crazy power trim. I like the simple click and trim one. I think it goes back to my AutoCAD days probably, before they had power trim. So there's a shape. Again, at this point, can we put sketch fillets in there? Probably. I'm going to just cut it and then do the fillet afterwards. So this now becomes a cut. Double click down to that face and it matches that 5 millimeters. If we want, we can grab this fillet from up here. We can drag it below it down to the bottom. Okay. And now since that feature comes after that cut that we just did, we can come in here and we can add to that feature. If you want to keep your feature tree clean, see how few features, the people usually have a competition. How many features can you create this part in, right? So you can do something like that if you want to, right? So there's that part of it. Oh, now we're in. Let's go back to our drawing here. At this point, we need to, there's a couple of things here. You see this balloon dimension down here in section view HH. We'll also, when we make changes, they'll be called out in balloons typically as well, all right? So up here you can see all these dimensions are ballooned. This dimension is ballooned. We try to show you where the changes are going to be. Okay? Again, helping you to get to get to the point you need to be. Okay, so let's go ahead and we'll cut this cutout in here, whatever, I'm not sure what to call it, groove, if we will. It's 30 millimeters deep, and it's offset underneath that arrow is called out as 30 as well. Okay, so this dimension right here that's underneath the arrowhead is 30, and then it's 30 back there. It's offset for 10 millimeters from the outside of that body right there. So let's go back into SOLIDWORKS, and we'll just sketch on this face. And we'll go normal too. Okay, I already know that I need to reference. I know I'm going to need to cut this part of it because I have to cut. So I need that part. So I can convert entities and grab that. And then I can also offset this, now that I have it, 10 millimeters. I'm going to reverse that. Okay, and that's what I want to cut. So now, since I have these, if we look back at the drawing, it shows in this view down here in the K, in section view KK, it's basically just an extension of these two lines, or that edge. So I can grab these two lines now and convert those as well. So what I'm trying to do is basically reuse geometry where I can, so I don't have to assume that I'm putting things in the correct spot, if you will. We'll grab this point and we'll drag it up to that arc or that circle, grab that one up, drop it at that circle. And then again, now it's some creative trimming, all right? I believe I need to trim that. Yep, there we go. Okay. So that's the shape that we want to cut now. We see our contour, but we don't want to cut at that surface. We want to cut it 30 millimeters in from there, and then we want to cut it 30 millimeters deep. So just like we did when we did the extrude, you can also do the same thing with cuts. You have the from up here, so it's going to be offset 30. Oops, clicked a little too quick. So this is 30. So you see it's offset, but it's offset the wrong way. We can flip it around. This actually, sorry, this one needs to flip like that up there this time, and then this is going to be 30. So a little difference there. Okay, so it's offset 30 and it's cutting 30 deep. Okay, and there's that. So we got that part cut out there. All right, so what's next? Let's go back and see. There's a couple more changes in here. I've already set, I believe I set all the variables. We can check that when I get back to SolidWorks really quick. But there is a change, I believe, to, this is now 2 by 30 degrees. Okay, that's a little tricky one there. You know, I think it's a little petty one to call out for a change. He's basically trying to maybe catch somebody on that, if you will. Okay, and then that should be it. We should be good at that point. Okay, all the other dimensions stay the same. We just need to make sure we'll double check those variables once we get back here. Okay, so let's just double check these. I can see compared to my list that's sitting next to me here, everything it looks to be matched up correctly. Okay, so let's go back here. We'll find that chamfer, edit this, and then this is going to be 2 by 30. Okay. So we'll save that. And at this point, then we should be done at that point.
How do you know which
Direction?
Yes, it's not a 60 on some of those.
That's a good point. That's a good question. I think we actually tried it 60 and 30 and it didn't, did it cut more or less? Because let's just look at it really quick. He's asking, how do I know if the 30 is going the right way? And that's another reason why I don't like this chamfer thing, because, I mean, you know, it's not a good way to do this or to call it out. If we put this to 60 instead, it's going to be wider the other way, right? So he's calling it, it's the other way that he's calling it out. I've never seen this in any of the exams where we're using like a non-45 degree chamfer. So
right, because if you use the face for that, you can run into a lot of problems. I think everybody, since you use an edge, you're fine. But if you pick the inside, just the two inside faces, one would go one way, one would go the other.
Mm-hmm. Yeah. So again, I kind of yelled at him for this. We've left it, but if I had seen if I ever saw something like this in like a regular exam, I'd kick it back to him and tell him, no, just get rid of this and make it a 45. Because like you said, it's not clearly called out on here. You know, it's just this. So wouldn't be a good. It's not something good to do to the user, if you will. Okay, so at this point we have our answer here is 13206.3.40. So let's go back here. And so this is a multiple choice. So we can see 13206.40 is B, and B is the answer. All right. So then at this point, what would probably happen is we may ask you to actually to make some changes to this as well. Okay. Kind of moving forward on that. So at this point, that's the demo, if you will, on the parts themselves. I know we have a little bit of time. We can get into something else. This is the best way to get a hold of us. Okay. Both Lars and Monty have my direct email address as well. If you guys need anything, they can get a hold of me that way. My team monitors that inbox, certification@solidworks.com. All this stuff that we showed you, the sample exam stuff, you can find at solidworks.com/certification. That's where all those sample exams are. So let's get back into SolidWorks. And if there's any questions or if we want to try anything.
I think my biggest thing is, can you like generate some, just on purpose, some errors as the model builds to see like the different kinds of errors that could come out and how you would fix it? So like if for example, like a line is not coincident, or maybe it's like some part gets overdefined, like it'll show up some yellow errors.
Yes.
Then like how would you go about finding where exactly that is? Because SolidWorks never tells you exactly where in the tree, right? Well, yeah. I mean, kind of does, but not very well.
So what he's asking is, like, it's basically what he's asking is like, how do you troubleshoot like a part that has a bunch of errors in it?
Yeah.
Okay. There's some logic to what you can do. Let me see if I can just open like a part that I can destroy.
Yeah, please.
It's funny is that whenever I try to create a part and generate errors, it's hard.
Yeah, right.
You can only make errors when you don't want to make errors. So in this one here, I think I may have modeled this one. So let's try this actually. let's go back in here. Let's look at the sketch for, I'm trying to think how I'm trying to figure out now how I can break apart
Yeah.
and break it. But if,
Right.
so in here, let's try what we did earlier, okay? Let's say we're taking this one and putting it into version 2 now. So what I want to do is I want to take this, I want to suppress this, okay? You can see we get an error. See, again, this one, the way I modeled it now is just much easier. You get an error here. I was able to fix this because I knew exactly what it was going to do, so it's easy to fix this one. The errors, you're correct. This one is pretty self-explanatory. It says an edge or fillet is missing. Let me see what else I have in my.
See, for some reason, my version doesn't have the arrows that come up and tell you like which feature this depended on and all that. Like, I have to go to child and parent and actually figure that out.
What version are you using?
I think it's like 2017 or something. You should have it though, right? But,
You have to be
it's
turned
probably
on.
a setting.
oh, maybe it's just not turned on.
Yeah,
Okay.
he's going to show you. There's a spot near the bottom of that with the errors and warnings.
Yeah.
Errors on the bottom.
Yeah. So this will see the ones so these are all the messages I've dismissed.
Oh,
You may want to, those are the ones that pop up, the dialog boxes that pop up.
Yeah.
But those first two, the show errors on rebuild,
Yeah.
I would suggest checking that on, and that's where that window will start popping up. There's a box on that window that says stop showing this. If you check that,
They'll say don't show
Probably
again.
what happened.
that's probably what happened. So you have
Yeah.
to go back in and let it know that you want to see it again.
Okay, cool.
Let's see, I'm trying to find the other thing, maybe under feature manager. So the other thing he's asking now is, you see these things that pop up here?
You right click at the very top.
Is that where it is? Yeah. Tree display.
And it's right in the,
Okay.
Oh, it's right there.
the one top.
Dynamic reference visualization. Yeah.
That's new in 18.
I think they're, I want to say
17.
17,
Yeah.
16 or
Not in
17.
16.
And in 19, I think we've actually added more to this. Like we've improved the way they work. So they become, I think they're bigger. They actually show you more things as well. But the quickest way, to find out is once you suppress thing, it'll quickly show you all the child features. Or if you right click into delete, right here, if you go delete absorb features, it'll put it in there.
Okay, cool.
Cancel out of it. Let me open up something. I'm trying to find something that we can break. It becomes a matter of just like trying to.
I think if you break it at the sketch level rather than the feature level, that might generate more errors.
We could, yeah.
If you just went into the sketch and maybe like broke a line or destroyed a dimension or something.
Yeah, let's go back to that part. Let's unsuppress this. Okay, so we're back here to where we're at. If we go in here, let's since that's offset there. Well, actually, here's I'm trying to figure out a way to. I wish I had something a demo that I could break and then fix for you.
Well, could you just go into the sketch?
Yeah, just go into like one of the sketches and delete one of the lines.
Yeah, just like break a line, like maybe power trim it.
If I delete that line,
The sketch will, the feature will blow up.
Yeah, the feature will blow up.
And then if you just rebuild it with the, see what happens.
Yeah, I mean that one's, so that one might be kind of common actually. 'Cause if you delete a feature or a sketch,
That's true.
things will it's basically what happened with the fillet. The edge is disappearing,
Yeah.
so that's what's causing that. But
Could you mouse over the error? Like, what's the enable? Yeah, see, it doesn't really give you suggestions like what should you do or like what's exactly missing, you know?
yeah, I would say that what happens is it kind of comes with in time. Like as you're going back and modifying something, as you start to click it and start deleting it, you'll think to yourself like, as soon as I do this, watch that feature's gonna explode.
I mean, my biggest fear is because I inherit a lot of sketches from people.
Yeah.
I make mods to them, and it's like if I mod something,
Yeah,
I mean, like for that for example, just getting rid of one line, now the whole feature is gone. It doesn't even attempt it.
yeah. So what I'll do sometimes is as I'm making changes, I'll roll back, and then I'll in this case, I would come in here and I would edit this, and then I can kind of see what's there.
Yeah.
And then it's like, so then if I see an error, it's like, okay, now I know that was right there. It happened right after it.
Yeah, that's what I resorted to.
The other thing is now watch, if we go back in here, okay, so we don't have to fix fillet 2. Okay, by fixing the cut extrude 3, we'll be able to fix fillet 2, right? And why is that? Do you know why? Can you guess why?
Because now there's a feature.
Because the edge is back.
Because the edge is back. But now, see, let's Control Q. See, okay, now this one didn't fix it. Okay, so that's because the edge ID of that, or the edge, or the
face ID is different.
I wanted to say face ID, but it's not a face, it's an edge, but it's the whatever the numerical value of that edge is different. Yeah. The address is different, so the software can't solve it.
It's not like
Constantine. It's Constantine. Yeah. I can do a thing just on troubleshooting if you want.
Because that's a big problem.
Seminar on troubleshooting. I know it's its own art.
Like I quite literally, I mean, I can probably generate parts like mad sauce, but like at the end when it all comes together, it's just broken everywhere.
Right. And making a little change to some parts will create a lot of errors.
Yeah, because I automate a ton of stuff, like I mirror things everywhere, and then there's always these issues.
Yeah. So it's and that's what he's saying is basically is trying to come back in behind somebody and figure out what they've done.
Yeah, exactly.
And so part of this is trying to create very robust models that can withstand changes as well. But again, there's sometimes the software just it can't handle it.
Well,
as good as you can model it, the software still is dumb in that respect.
Because I'm wondering if the software is smart enough to even just like this, because what mine does sometimes it displays a list of all these problems, and then it's already hard enough to understand it, but some of it's pretty useful. But like, is there a way to visually like force it to highlight where the problems are? Because the only things I get are like yellow lines if there's a rebuild error. Like I don't get like, here's an issue, here's what it should look like, stuff like that.
Yeah, so
it only does it when you go in to edit the feature itself. It'll show when you go into the property manager, usually on the graphics area, there'll be something like if you feel it can't do it, it'll highlight which face is not there.
Yeah, so
dig in to really.
You really do have to dig in.
Okay.
It's not gonna be something on top.
Fair.
So let me show you 2 things. So one, to fix this fillet, I alluded to this earlier. If we come back in and edit this, you'll see up here, missing edge 1 and 2 are in mustard color. They're highlighted. If you highlight one of those and then reselect the edge, it'll recapture that information. So that will be helpful in some respects because that might help connect things down the road as well. So it's reassigning that address instead of just like burning down that address and giving it a whole new one.
Yeah, because it's now part of the full list of the.
And now it's pointing. Yeah, so it's maybe. So I'm guessing that in the background, it's reconnected that broken link, and everything downstream will now work as well. So that's the one thing to consider when, especially with like edges with fillets and chamfers, is reselecting the edge instead of like I did earlier and deleting them.
Stay in the feature.
And that's probably why it's done that way. So that one's fixed there. Let me show you guys. I'm just going to sketch on the back of this model.
So, and actually, my last question is in regards to sketches. A lot. Just like most of the time I see people when they sketch stuff on different planes, they would just select a plane and then create a sketch off of that. So why not just create a bunch of actual planes themselves?
I would say only do it if you need to.
Okay.
For cleanliness of the tree, for time savings.
Yeah.
Obviously, like on this part, like on this face up here, on this, I've moved a lot. I've generated a lot of stuff off this edge. Right here, right?
Because what you're doing is 3D sketch, right?
No, it's a 2D sketch because it's on a planar face.
Okay.
It's a flat face.
Yeah.
It doesn't matter what angle, as long as it's planar, you can sketch on it.
Okay.
Okay. But if I change, like, if this is referenced off there, if I change something referenced off that face, it's gonna change everything else downstream as well.
Yeah. Okay.
So you do have to be careful with it sometimes. Let's talk a little about sketch errors. This is one way that when I first started doing this is the one way I would sketch this little boss out here. Okay, I'm taking advantage of sketch tools to make this a using that corner, okay? But what it's doing, you see this, it's creating these center lines to make it kind of even. So if I now take and dimension these to 60 by 60, okay, the way that it's created the sketch, if I want to put that 10 millimeter or the 15 millimeter fillet in there, let's say I want to put a sketch fillet, okay, of 15 millimeters. As soon as I select that corner, look what happens, okay? It's telling me that now I'm changing the length of that line, all right?
It's not centered.
It's not centered anymore. And I don't care if it's really centered. I wanted to center a corner rectangle. That's what because I wanted to start from a point and drag the corner away. Okay, so if I hit yes and then click OK, and look what happens to the sketch. Completely blows up, right?
Yeah.
Okay, I mean, that looks scary.
Yeah, that's exactly like what I.
Yeah. So how do we avoid that? Okay. So in this case, it's you got to choose your battles or choose your efficiency or your level of efficiency. So now I can do that. I can grab these two lines and I can do a convert entities, and then I can draw two more lines this way, right? And then I can trim them. You see how much longer it's already taken me?
Yeah.
Okay, and now I can, let's dimension it. We'll just do the same process. This should work. Notice I did say should. I like to disclaimer. And then if I come in here and I put this fillet on there, see?
Yeah.
So you almost have to choose your battles of what you're,
Yeah.
So in this case, so the reason I don't do that anymore is I just, now I disguise it by saying, well, let's do the fillet later.
Sure.
Because I'm a demo guy, right? I'm doing a demo.
Okay.
So I want it to look good. But I've learned my lesson too.
Yeah. I'm glad I'm not alone.
No, it happens to everybody. Yeah, I mean,
yeah.
Yeah, I mean, to be honest with everybody here and on the phone, we had all these numbers dead on today. It's tomorrow night, it may not be the case. So it's one of those things, but I like when things don't work.
Yeah.
Especially in a group setting. I'm not selling anything. So
And
you guys are already using the software, so I don't care if it breaks, right? But now we can figure it out together. Why does?
it's not like SolidWorks would be smart enough to have solved that on its own.
No,
There's no like autos.
It's a computer's doing what you tell it
Yeah,
to do,
okay,
right?
all right.
Right. Essentially, that's, I mean,
Yeah.
they're the dumbest smart devices around.
Yeah.
So that's, I mean, you guys are all in software, so you understand that.
I'm so used to autocomplete.
Yeah,
You know,
exactly.
like, highlighted here, here's a problem.
Yeah. So that, again, I mean, that was a perfect example. Like somebody will see that thing blow up and like, oh my God, what do I do now?
Yeah.
And it becomes a mess. So, listen there.
Thank you.
We do have a little bit more time. I'm sure you guys are on time. You want to see some other stuff?
More stuff.
Yeah. So let's.
So we just have the parts to create or assembly.
There's an assembly. So this is the hardest one. This is the hardest segment. So this is the one that I focus on. The second one is you can download parts with configurations and make some changes to it. And the third one is assemblies, creating mates and stuff like that.
Thank you so much.
Yep. So that's why I focus on this segment, and I don't want to give it all away either, right?
I need to see the other stage also, the other segment.
Yeah, segment 2 and 3.
2 and 3.
Yeah. Do you do assembly modeling? Did you create assemblies with parts? Then as long as you know how to do like basic mates, and there's nothing too crazy in there. So they're the simpler ones, the simpler segments.
Because last year I take this exam, but I just stuck in this stage.
Yeah, you came. I think you might have come in a little bit late. I think my very first tip was to take them in reverse order: 3, then 2, then 1. This is definitely the hardest segment 1.
Yeah, I was in the waiting list and I just start very late.
Yeah.
I didn't go to the other.
No.
stage.
So when they distribute the codes next time, do it in reverse order. Do 3, then 2, then 1. All right.
You're gonna
That's.
show us the.
I don't have anything set up for. I can run through some some assembly mates, basically.
How about the second one?
The second one is just all about configurations, basically. Going in, selecting configurations and changing only certain configurations and going back. And I think there might be some error fixing or something in there. It's been a while since I take it. Again, usually I just show this one because it's the most complicated one. Let's open up some of the.
Is it all practical exam now, or is there still a multiple guess section?
On the professional levels, it's always, he's asking if it's just, if it's all hands-on or if there's any like a theory. So on the professional level stuff, it's always gonna be all hands-on. There won't be any questions like, what do you call this feature? Okay. On the associate level, CSWA, I think there's like 4 or 5 questions that are theory, or not theory, but like interface stuff. And then there's some hands-on. But once you get to professional or the advanced professional or expert, it's every question is you're gonna be using the software to answer that question.
Okay.
Yep. Let's see. So this is something I kind of show you guys too. I don't know if you guys work or if you ever encounter in place or in context assembly modeling. So that's what this thing is based on. So what this part here is actually is, kind of hide some of these parts. This is the part for the sample exam for the new mold making exam that we just released. So this is a part that I had sitting on my desk from a product. I just grabbed my calipers and just kind of halfway measured it. But this is basically, if I open this part, it's transparent. So I kind of select it. Basically like half of like a 360-degree camera case. So I had one sitting on my desk. I just quickly measured it. I was trying to find a good plastic part. So on this part here, it's for the mold tools exam. Mold being my background, it just kind of, it goes back to what I used to do. So let's open this part. You can see here, there's some like different shutoffs and stuff in here, right? From a mold standpoint, this is basically how this would be made. Okay, if we were to make this part, this would be, it's actually kind of, I don't think it's really cylindrical. It might be conical. Yeah, it's actually probably conical, a little bit conical. But everything references things. So on this part here, let's open up this part. If you look in here, there's a couple of these in context references that point out to the end. Basically what happens here is if we go back and let's roll up here and look and see. So this is what it starts out with. There's called creative extruding. And then there's a cavity feature. So inside this part, you can see it still looks whole, but let's take a section view. And now you can see by using the cavity feature, I've actually cut away anywhere that other part touches is now been cut away inside there. Right, this is basically the process we used to do.
What's an offset?
No offset.
Okay, no.
Yeah, so in molds, the part would actually assign a little bit of growth to it because plastic shrinks when you cool it, right? So that it's already calculated in there for it. So then it's like basically a matter of like trying to cut these things through here. So let me get out of this section so you can see what's going on. So basically just kind of get rid of this stuff. Eventually get to where you can actually see. So there's the part again there, all right? And then what I want to show you is the part that goes out to the end. So there's one part there, okay? This creates that shutoff at the side. So let's look at that sketch. So we're looking at the part level now. If we look at this sketch, and if we zoom into it, see it's fully defined, but there's no dimensions on there, right? So how can that be? What it's doing is it's referencing the geometry of the plastic part itself. Okay, so let's measure this actually. Let's try something. Let's see how long this is. That's 15 millimeters. Okay, let's go here and we'll just get out of there. Okay, so we know that width of that opening is 15 millimeters. Let's close this. Yeah, we'll save it. Let's open this part again. Okay, so this is the part model that we got. Okay, and somewhere in here is this cutout here. Let's edit the sketch. See, there's our 15 millimeters, okay? So let's change this to 18. We'll click OK, and we'll rebuild it and save it. You know, this is gonna ask us, do we wanna rebuild? Or I guess I've already accounted for that, okay? I haven't done anything to this part. Let's just open this part. And let's go in and edit that sketch again. And let's measure this. 18 millimeters. Okay, so that's in context assembly model. I'm not sure if you guys do any stuff like that or not. I kind of wanted to point this out because this is when the guy that just left, when he's talking about trying to figure out and debug people's models, stuff like this can get really hairy. Just trying to figure that out. So what I had hoped to point out to him was that sometimes you got to dig deeper than you really have to go. But something like this is rather common. The nice thing is that from a standpoint of, from a standpoint of changes to a part, that's probably rather common, right? I mean, that's probably a good example. It's like,
One drives the other.
yeah, that part is now the connector we're going to use is not going to work. We need more pins. We got to go wider. So now I'm able to just change the part model and everything. I kind of updates from there. To me, that's the power of parametric CAD modeling. A lot of people don't like to do that kind of stuff. So let's spend about half an hour or so, 20 minutes, just doing some of the assembly stuff that you can get into. So
Okay.
I'll open some of the fun ones here.
For the last year, I create the parts and it looks like the same, but I didn't get the exact mass that I was looking for.
How far off were you?
I don't know, just 10 or 20 like that.
Grams or so?
Grams.
Yeah, and I can with 100% confidence tell you there's something wrong in the model.
Yeah, but I couldn't figure out what's
If it's a decimal place, that's like a 3-place decimal,
No, that's not.
you can just take a wild guess. And
Yeah, because
stab it.
I stay between two options. I didn't know which one is closest.
Yeah, and that's the thing is that like as you saw though, if you choose the wrong, if you go ahead and round off, it's like okay, I'm close. You could be going down a rabbit hole. You can get further and further away, and now you're just so far gone that like when you get to the next change, no, you're just completely destroyed. You can always send them to us, so we're more than happy to look at it. Like it's like, hey, what did I do wrong? So like this morning, I couldn't figure out what was going on with that part. I sent it to my guy. I said, what am I missing? And in the few minutes that I was waiting for him to get back, I was playing with it. I looked at the drawing. I said, that's what's wrong. And I changed it, and boom, that was it.
So I just missed one dimension or
Something, yeah. If you're on that first question that you submit, she's basically asking if the value is wrong, what should I do? Where there's multiple choice, if you don't match one of those within like 0.01 grams, go back and look and investigate. There's something wrong. So we thoroughly test all things. Like the CSWP exam, this version has been out since January of last year or this year. So it's thoroughly vetted and thoroughly tested. If somebody writes in today and tells us your exam is wrong, I should have got this question right, we know that they're wrong. We just have to figure out what they did wrong because it's been completely tested by now. Every version of every model has been thoroughly tested by now. So in those cases, you can always, like if you go through the sample exam and if you just can't get that number, send it to me and say, what am I missing? And most of the time we won't tell you exactly what you're doing, but we'll say, look in this area because we want you to figure out as well.
oh great.
Yeah, feel free to send it to us. And I mean, you'd be amazed, even though we have as many customers as we have, my guys sit there and they work through the inbox all day long and they answer people back within an hour usually.
Great.
Cool.
Thank
Yeah,
you.
so unless we're out on the road somewhere, they're very responsive. And they love to do that stuff, like to kind of debug things. They love to try to figure out where their errors are. Let me open.
You've taken the same type of test 3 times now.
Yeah, don't be frustrated if you fail it.
No, SolidWorks World, and then we had that one class together where every midterm and final, he does it, he kind of structures it the same way where you have to come up. He doesn't care about anything except for the weight at the end of the day.
Yeah, in
So
the class, I didn't have the problem.
it's always when you're on the spot of something.
Yeah. And don't feel bad. I the first year I took this exam when I was a customer, I failed it. And I had to wait a whole year to take it again.
Because, 5 minutes before and test start, I just decided to,
Oh, yeah, that's fine.
I went to the waiting list to get it.
Yeah, the main thing is as long as people are learning something, that's what we want. That they can learn. If they fail, they learn. It's like, that's what I missed. And I guarantee they'll never do that again. And this, you see it the way that I model this stuff up here. I know where to avoid because I've gone through those things, I'm not able to model a part 100% exactly the first time either. We try, but. So let me show you, we'll work through 3 of these simple assembly things. So this is my bad attempt at like a dent puller, if anybody knows what it is to fix cars. This is just a simple assembly. What I want this thing to stop down here and I want it to stop up here, right? So what I do is I'm just clicking and dragging that part. Okay, this is what's called a flexible assembly. If you look here, this has a little dash sign, minus sign. That means it is not fully mated. Okay, there used to be a way to fully define or to make them rigid, and it's moved 10 times in the last 5 years. So where you could set it to, you could fix somebody's assembly with one click. Okay, so there's a couple things away. Let's say that we're designing something that we want to calculate the way things move. Okay, let's say like you're designing a machine, and as you open a door, another kind of door moves with it. So you want to see all these things move together. I can quickly, but you want the physical dynamics of the machine or your assembly to perform the way they're supposed to. So you can move this way, or you can come up here and you can grab move component up here. So when you activate move component up here, you have more options just like than a free drag. And one of them is collision detection. Okay, what collision detection does allow is you can have it stop at collision. So now what happens is if I drag this, you can see it stops at those faces, and you can actually see the faces change color as they stop there. But imagine if this assembly had like 10,000 parts in there, and you're trying to move that with physical dynamics. To move from here to here is probably going to take about 3 hours of crunch time on the processor to sit there, because it has to see what's going on to do that. Okay, so we can simulate, or not, maybe not simulate, we can actually kind of mimic that motion through mates instead. Okay, so then we can see how things move with each other without having to ask the software to calculate every little single step that's moving. So let's go in here, we'll grab the mate tool since we're in assembly. And under mechanical mates, we're going to do or is this advanced mates? Advanced mates. It's going to be a distance mate. Okay. So what I want to do is I want to set a distance between this face and this face. Okay. And I want that distance to start at 0. Okay. Now what I can do is down here is I can put limits on it. Okay, so right here, what's the minimum I want them to be? I want them to touch, I want the minimum to be 0. The maximum I want to be, can anybody guess? 8.75, the annotation that's floating around in the background up there.
8.75 minus
So why I chose 8.75 and not 9, that's why it's an annotation in the background, because I always forget the number. So now I type in 8.75, and then we'll click OK. We'll get out of the mate tool. Now let me show you what happens. As I drag this thing now, it still drags around. Moves around fine. As I drag around, it stops. Okay. As I drag it this way, it stops up there as well. Okay. At this point, SOLIDWORKS doesn't care what this geometry looks like back here whatsoever. All it cares is that the distance between these two faces has not exceeded 8.75 inches. Okay. So that's a distance with a limit mate. Okay, this is what's considered like an advanced mate, if you will. This is another, maybe I'll come back, I can do this presentation sometime.
Okay.
There's a whole bunch of, like basically everything other than the standard mates. I show you how within sample that you can go through. And maybe we can come back and do that next time, but I'll show you a couple of them this time. This one here, let's see what the next one pops up. Cam mate. Okay, this one may or may not work. On my computer, for some reason, it does not like this assembly, and it always kind of, it goes all crazy on me. All right, so what I want to do is, and probably because I just moved it, it's probably going to screw it up. We want these valves to ride up along those cam lobes, okay? So I've pre-positioned some things. You saw this spins in space. These can rotate, but they're positioned on the X and Y the other way, if you will, or the Y and the Z in this case. So again, under the mate tool, under mechanical mates, now this is the cam mate. And I think there actually is a cam mate in the segment 3, I think. I have to go back and see. So this, if you guys are using 2016 or anything earlier than 2017 or earlier than 2018, this got highly simplified. Okay, basically, especially the path. All right, so the rule to make a cam mate is you can have a point or a sphere follow a series of tangent faces. Okay, so we have a point right here, and then these faces, guess what, are tangent faces. Okay, so prior to 2018, for the cam path, it was an expandable box of however many faces you have that were tangent to each other. And guess what? You had to select all the tangent faces. Okay, it didn't make sense. The nice thing is, so in your guys' version, if you're not using 2018, you can right click on that face. You can't now, but in the older versions, when you right click on it, there's an option to select tangent faces. So that's the shortcut for it. Otherwise, you have to select all the faces. they finally figured out that since it has to be a series of tangent faces, just have the user select one face and then grab all the faces for them, right? So cam path, when I select that one face, it grabs all the other faces together, okay? Yours are gonna look different. If you're not in 2018.
We're in 2018 now.
Oh, you're in 2018? Okay, then it should do that. That should be there, okay? The cam follower is just, which face I grab is the point. So we grab that point, you should see it move into place, okay? So at this point, let me just grab this and let me show you how it's supposed to work. Now as I grab that, you see that point is basically gonna ride along those series of tangent faces, okay? Again, the key is it has to have a point or a sphere, and then it has to be a series of tangent faces. So we modeled like a star, and then in the very corners of the star, we just put a tangent fillet in there. And it allowed us to select it and rotate around it, okay? Let me try and create these other mates and see if it actually worked. Maybe they fix it in Service Pack 4. But again, here, it's just the cam path, and then the follower. It's so much easier now. It's just 2 selections, which is how it should have been all along. Again, just the face and the point. I wish I could show you what it used to look like. It was a pain in the butt to select all those faces. So this one's actually working. Oh, see what happened to this one now? It's inside out. So for some reason on this assembly, on my machine, it always kind of screws up for some reason. And I've sent it off to development and they cannot figure out what's going on. No one else has reported it. It's just something with my machine or this assembly that turns it inside out. But you saw that it was working. There's probably a way to fix it by flipping this or something. There's got to be a.
Nice down the road.
See, it's not.
Doing
Yeah. So it's really strange, and that's why it's. I mean, you saw it was working. So again, that's the cam mate on there. Much easier to use, in I said, than it was in the past. And you see, they're very simple, like assemblies, just very simple ways to kind of display these. So this one here, this is using the hinge mate. And this could be, the one thing I like about this mate is that it could potentially be 3 or 4 mates built into one. So when you're talking from like an assembly performance standpoint, the fewer mates that you have, the better the assembly will perform. Okay, because every time you rebuild, you do stuff, it goes through and it looks down through all these mates and to make sure they can still solve. All right, so if you have 1,000 mates versus 500 mates, it should be twice as fast. Okay, so obviously it's a mailbox. We know what we want it to do. So let's go ahead and let's grab the hinge mate. Under mechanical mates, I think, hinge. So we have a couple of selections up here. So concentric selections. So that's going to be this. Those 2 diameters, okay? And now it's asking for coincident selections. So on this, the way I modeled it so these tabs are basically 1-to-1 or rubbing those things. Probably not the best way to model it. The mailbox will quit working after a while, right? The ideal way would be 2 planes down the center and then allow some space in there. But because of the way I modeled it, we'll grab this face right here and then we'll grab this face out here, okay? Now, before I select it, okay, and click OK, because it's solved. The mate is solved, and it's satisfied. We can accept it. But what's going to happen if I click OK and I grab that door? What's it going to do?
It can collide.
It's going to spin in place, right? Because we haven't limited that. So I can click OK, and I can go do a limit mate, or I can go right here, and there's an option. I can go specify angle limits. As soon as I enable that, this expands. I get more options over here. All right, so it's always good to check out the boxes over here and see what else you can do. So now by doing that, for the angle selections, these 2 faces here, much like that we just did with the dent puller, it's just specifying. So what's the minimum we want is 0. We want it to be 0. And then the maximum we want it to be is 90.
90.
And then click OK. And then now, if we grab it and drag it the right way, a little better angle there. It's kind of hard to, let me drag it somewhere else. Come on. Where you stop, it's graphically, it can be an issue here. Basically what it's doing is it's allowing us to drag, there we go, almost. This didn't used to happen in the service packs. Basically what's gonna allow it to do is it's gonna allow these 2 faces, they may not be perpendicular now. It's gonna allow those 2 faces, we got close. I actually went over for some reason. It's basically just going to keep it between those two angles. All right. So if we go down here, actually, you'll see they're parallel now. Okay. So again, on that one, if you look, we could have a distance or a limit mate there, a concentric mate, and a coincident mate. So there's at least 3 mates tied into one in there in that case. All right. So that's, again, talking about trying to improve assembly performance. That one's a big one there. Let's open one more, and then I'll let you guys get back to. Let's see. So yeah, I have a whole bunch of these things up here. Try to find that one that's really good. Profile center mate. We'll do that one. I can remember how to do it.
That's a good one.
Yep. And then let's open one more. Oops. Centric.
Change the coordinates.
This is a good challenge. Who can mate this yellow part? Okay, I want this part inside this block. Okay, so inside that, it basically sits kind of like this in that hole. Okay, centered in that hole, centered between those 2 blocks, and not able to rotate. Basically, with one mate, I want that to disappear. Can anybody guess how to do it?
One mate.
One mate, only one mate. So actually,
I'm sorry.
I was going to expand that, but that gives it away. So take this part, put it in, center it in that hole, and then put the block between those 2 faces, but also not allow this to rotate. Fully defined, and not using lock concentric. And I think that's in 2019 anyways, like all concentric.
No,
parts.
it's actually.
Anybody get? It's a basic mate, actually. Anybody? Okay, let me show you.
Width and a concentric with a lock.
That's 2.
That's 2.
Yep. All right. So if you notice all day long, all my parts, the origins are all completely turned off. I hate seeing origins. To me, it just bugs me.
Gotcha.
But in this part, the origins are on. So that's a dead giveaway. That's one of the giveaways here. So I'm going to control select these 2 origins. Okay. All right. And I'm going to we'll hit mate. And it's going to move them on to a topic. Again, these are modeled in the way that I want. Okay. There's an option right here. So now it's made in coincident. Okay. But it's also, I have an option here to align the axes.
Oh, that's cool.
So I click OK, and then click OK again. That part's fully defined.
Is that new with 18?
That has been around for, I don't know how the align axis has been around for a long time. One of the things I point out in this presentation, next time I come back and I'll show it to you, I point out quite a bit, is there's a lot of little options in the make dialog boxes that people just do not look at. Okay. So a lot of people say, well, that's cheating. You modeled this part to work that way, right? But that's another point that I want to make is when you're modeling an assembly, you should think about how it's gonna end up. So when you start to model your parts, you can take advantage of those things.
Well, just one more point on that is that I show people if you go into an assembly with those 2 parts and you just insert them and hit the green check mark, they're both going to be locked in position without any mates.
They'll be with probably they'll be fixed. Yeah.
But if you model with the XYZ correctly, you can just drop stuff in and find different things.
Yep. Yeah, and that kind of leads you down. That'll lead you down the road to like the automates and all that stuff. So that one's kind of a fun one. Everyone always gets stumped on that one because it's so simple. Everyone's looking for some complex.
Question.
Would you be able to do a hinge with 0 range of rotation?
He wants to know if we can do a hinge with 0 rotation. I don't see why not. You can just set.
Too much of a hinge.
I don't see
You
why.
wouldn't be much of a hinge.
I don't see why, but I'll say why not.
Yeah, I mean, you could probably, if we go back and look at that one, you could probably just the mailbox. You could probably just do a concentric and then lock it in place. So yeah, the hinge will just give you the motion that you want. So when I go through these, I explain why you want to maybe do some of those things. And let me show you this just one more. So this is a profile center mate. This was new in 2017, I think, 2018, maybe 16, 17, somewhere. I forget that they're all the years they all kind of mesh together now. So this is, I'm not sure how many old people are on the phone or that remember drive-in movies. Before we used to get out of the house to be able to go watch movies. We want to put this box onto this stand right here, right? Okay. And I want it to be centered on there. You can see this is, I like to call this what I call like unbalanced geometry. you look at that face, there's 3 holes instead of 4. And it's on purpose because I want to show you that it's the way this works. So you grab the mate tool, and under advanced mates, profile center mate. Okay, what this allows me to do is to select this face and this face, and SolidWorks, and it's nice enough to spin it first every time. I don't know why. What it's doing is it's looking at the volumes of those 2 faces, or the surface areas, I guess, and it's calculating how to center them onto each other. Obviously, I need to rotate it back so it gets back to where it was, like that. And once I click OK, that box is fully defined on that face. Okay, I don't have to create planes. So in this case, maybe we might have interface holes on this face as well. And so you might match it to that. But let's say it's going to get welded and there are no faces on there, or no holes. Okay, you'd have to create planes or distance dimension or something like that. Okay, even regardless of this face being unbalanced, you can dimension from this edge to there and so forth, and it's completely centered, right? It looks at the geometry and does that. Okay, same thing with a round part. So if we go back here, we go to profile center. If I select this face here, and then the underside of this face, okay, before I click OK, again over here, lock the rotation. Okay, I can lock the rotation. Click OK, it positions it, and that part's fully defined now as well. Okay. Again, instead on here you could put that's probably just a concentric mate, right? And you can lock concentric mates as well. But it's to point out that there are these options in the features that a lot of people skip. Okay. There's another one that I do that how you can combine a bunch of mates into one folder. And so when I come back next time, I'll show you guys all that. And, there's just a lot of little underutilized things inside there. So that's the kind of stuff that you'll encounter in segment 3 is different kind of, they say, create this mate. And go from there. So, any other questions on the phone or here? Hopefully I repeated the questions well today, hopefully.
Yeah,
You did.
yeah.
You did a great
Actually, the person who had asked for them to be repeated said you're doing a great job of repeating everything.
Yeah, he wasn't bugging me as much as he usually does. George.
So again, I'm going to leave it up. I'm going to pass the codes off to Monty, and he'll distribute them through there. If you guys need anything certification related, ping him, let me know, and he can put you in contact with me, or I can go through there. Whatever you guys want to do, anything so that we can take care of on that end.
Because I'm hoping that at the end of this session, that everybody's excited to take this test. We could probably do another session, and Lars can kind of maybe do getting prepared for it also, if we needed to do a follow-up for this. But the more people that become certified professionals within Google, makes you stand out above the rest of the users in the crowd. I mean, Lars is a professional.
Yep, from way back when they were doing it on paper.
Yeah.
I got mine. Yep. Mine was.
But thank you, Mr. Puckett, for coming. Always a great.
Thanks, Mike.
Thanks for having me.
Thanks, Mike.
Next week we've got another SolidWorks corporate presenter coming in, showing us some tips and tricks.
Is that Brad Williamson, by any chance?
That is Mr. Williamson
today.
And we're even going to have another one on industrial design the following week. So we've got a bunch of them. I'll be sending out emails to everybody, and we'll send out the recording of this when I get it finalized. A couple
Well,
days.
I'll talk to Mike, and he'll be back out again shortly.
Yeah, and hopefully we'll see some of you guys out in Dallas at SolidWorks Show.
Yes.
Yes, indeed.
Yes.
You'll be there. All right.
Oh, there was probably about 8 people.
Probably an audience of about 18, 19 people. So,
I've traveled like all the way across country to user groups that had like 5 people on.
all right.
So this is easy. So it's